So this video looks at a way in which we can undertake an inferential statistical test on categorical data using MS Excel. The data we're looking for here is exclusively categorical. We have a group of students and we have their gender and their eye colour. We don't have scale variables such as height and weight or exam mark. So we have to think, what can we do with these data? What hypotheses can we formulate? Well, we can perhaps hypothesize that there might be some differences in distribution of eye colour in the two different genders. So therefore we could have a null hypothesis that states there is no difference in the distribution of the different eye colours across the two genders. And our alternate hypothesis would be that yes, there is some sort of difference between the eye colours that we see in the two different genders. So for example, it could be that most females have blue eyes. So how do we actually test hypotheses of that sort? Most inferential statistical tests will not work with data such as these, which are categorical, but we do have the chi-square test. That basically compares observed and expected values. So what we're looking at are our observed values of the data that we're presented with. And what we will have to do now is to calculate expected values based on the assumption that the distribution of the eye colours is even across the two genders, and then we compare the two. The chi-square test compares observed and expected. So proceeding to undertake the test, then the first thing we do is to summarise these data into counts. How many students correspond with each of these categories? And to do this, then we summarise the data by means of a pivot table. So we go to Insert, Pivot Table. I shall put it on this page and press OK. And we now have a field on the right-hand side which allows us to generate our pivot table. So we need to put gender and eye colour in the rows and columns, either way around, and then the number of students gives us the actual values that we need. So that generates a table which has a set format. So what I'm going to do now is to copy it and put it into a format that's a little bit easier to use. So right click, paste special, I just want the values, OK. And now here I can put gender, which is what I've got on my rows. And here I can put eye colour. Widen some of these columns so that they're a little bit more manageable. And we notice that we've got totals here across the bottoms, the totals in the columns and totals in the rows. So what we've just done then is to summarise the observed data, the data that we were presented with. Now, in order to carry out the chi-square test, then we need some expected data, data that we would expect if the distribution of the different eye colours is the same across the two genders. So I'm copying the data once again. I'm generating yet another table down here. And this is going to be my table for expected data. And in order to generate this table, I need to remove the values that I had in the observed and use my totals to generate the expected values, assuming everything is even. By the way, before I do that, I just put zeros in the gaps above. Wherever we have a gap, it's a 0. So this is where a little bit of arithmetic comes along, and we have to use the formula function in Excel, which means putting in an equal sign. So what I need to do here is to actually multiply the column total by the row total and then divide by the grand total. And I need to do that in all 6 of my little cells in order to get my values. So equal sign, highlight the column total, put in Shift 8 to get an asterisk, meaning multiply, row total, backslash as divide, grand total, enter. Then I continue to fill my cells in the same way. Equal sign, highlight the column total, multiplication asterisk, row total, backslash, grand total, enter. And once again, equals, column total, multiplication asterisk, row total, backslash, grand total, enter. And then for the males, I do exactly the same. Equal sign, column total, multiply asterisk, row total, backslash, grand total, enter. Once again, you can see this would be a little bit monotonous if you were having to do it for a big table, and there are shorter ways of doing it, but I won't show you them now. Last one, equals, column total, multiplication, row total, backslash to divide, grand total, enter. We've now got our full table of expected data. So now we actually do the chi-square test. Unfortunately, our data analysis tools don't stretch the chi-squared, so here we have to use a formula. So the formula will actually generate a p-value for us. So I can actually put my p-value in here ready, and then in the next cell, I'll actually put the formula I need. Once again, I start with an equal sign, and I start writing chi test, and there it is, select it, and it prompts me to put in ranges of values. So the first range it wants is the actual or the observed data, so I'll highlight those. These are the ones in the middle, not the totals. Then I put a comma, and then I put the expected range, the ones we just calculated, and then I press enter. And here's my p-value that's been generated from that little calculation. 0.025 continued, which of course is less than 0.05, and consequently we can assume these data show that we ought to reject our null hypothesis that there is no difference and accept an alternate hypothesis that there is some variation in eye colour in the two genders. And in fact, it would appear, for example, that there are quite a lot of brown eyes in the males and quite a lot of green eyes on the females.